Question in front of us is for making standard resistance, wire of following material is used. Okay, so for standard resistance, okay, you need to take care what type of wire we use is. Okay, first options are in front of us. There is nichrome, copper, silver, manganese. Correct answer will be manganese. Next question we have material used for heating coil is. Okay, so for heating coil, which of the following material we are using? That is first one option we have nichrome, copper, silver and manganese. Okay, so here for heating coil we use nichrome. So you have to take care of this concept in your brain. That way to use for heating coil purpose or for resistance purpose. So that's a different. Okay. Yeah. Next questions we have two resistance 10 ohm and 15 ohm connected in series. A cell of EMF 1.5 volt of negligible resistance is connected between their ends. Then current flowing through 15 ohm resistance is 60 milliampere. Potential difference this, and this. So basically in this question, what's happening? Basically in this question, what's happening? See, in this question, we have a potential applied. Okay, potential is over 1.5 volt. Okay, and resistance of 10 ohm and 15 ohm we are applying. Okay, so resistance of 10 ohm and 15 ohm we are applying. Okay, and this is connected in series. So if I will ask you first find out R equivalent. Once you find out R equivalent, what will be R equivalent? 15 plus 10, 25. Okay. So once you find out equivalent, once you find out R equivalent, then you can easily find out current. So because there is no internal resistance here, so from here you can find out current easily. That is 1.5 divided by 25. Yes or no? So now we are moving for calculation part. Okay, and okay. So from here, current will be equal in both. Okay, in both the resistor. Okay, because it's connected in series. Okay, so because it's connected in series, so current will be equals to both. And once you get the current, you can find out okay, potential as well. So options we have first options you can see L C R true like this. So this come to the calculation part. Okay, I'm doing calculation part here. Okay, so basically I didn't mention your calculations. If you solve it, you will get your answer. Okay, so you can go through it, the concept, you can do it. Okay. The following table gives the current I through the two devices for several values of potential difference B. So here we have a potential as well as current. Okay, and device 2 as well we have potential and current. Okay, see here, so here I'm asking you that which device is ohmic and which device is non-ohmic. So simply what concept you need to apply. If V equals to IR, you are using V equals to IR means because here voltage and current is available. So what I'll see over here, that relation between voltage and current should be directly. So if I get voltage relation between voltage and current is directly, I will say that it's ohmic. Otherwise it's not ohmic. Otherwise it's not ohmic. So this is the concept only you need to apply one by one and check it. Is it directly proportional or not? And finally, after these options are in front of us, and options will be device one is ohmic and two is non-ohmic. So I hope you understood the concept how to approach the questions. Next questions. Potential difference B is applied across a device with resistance R causing a current I through the device. Heating effect produced in the resistance in descending order for the following variations will be. So basically, you need to play with the heating effect. You need to play with heating effect. What is heating effect? I square RT. So you need to play with I square RT by different variations. Variations I'm showing you and try to find the answers. So V is double, R is unchanged. Okay, following variations will be I is double. So what we are doing here in the question? What we are doing? V is applied already. Okay, and here causing a current I through the resistance, heat energy produced in resistance in descending order. For the following variations will be. So you need to arrange the descending order out of this. So I'm giving you first options. So this is the descending order. Okay, this is the descending order. So B is double, R is unchanged, and this. See, if you are confused a little bit over here, this current and resistance use this relation, no issue yet. If you want to use for potential, so we use this relation B square by R into T. So this relation will give us a heating effect here. So apply these one by one and check it in decreasing order. So answer will key will be A, B, D, and C. So now you can solve these questions easily one by one. Okay. The next questions we are moving. We have list one, we have list two, and list one and list two is this. So here you have to play with the value of alpha. Value of alpha. So alpha is greater than 0, less than 0, either positive, negative, and all. And this list one we have thermistor, carbon, nichrome, constantan, or magnet. So for constantan and magnet, we follow the same ratio, same values. So here answer key will be first one. So we'll go thermistor. So thermistor may be positive or negative. Thermistor may be positive or negative. If you talk about carbon, so alpha is negative. And if you talk about nichrome, so nichrome, its alpha is very high. Its alpha is very high. That's why we use at high temperature. If you talk about constantan or manganese, so alpha is almost 0. So it's factual questions. You need to take care of all this concept in your brain. Some of the time questions comes in front of you, so you can solve it. Otherwise, leave it. Otherwise, leave it. No issue in it. But try to take care of the concepts in your brain. Next question we are moving with list one. We have already list two. I'm giving you. This is superconductor, omiconductor, semiconductor, non-omiconductor. And this and this. It's easy questions. So this question is not to leave. So if you know the concepts, you can do the questions easily. So if you attempt this question, so answer key will come. Second means if I'm talking about superconductors, so superconductor resistivity is almost 0. You know it. If you are talking about ohmic resistors, so for ohmic resistors, it must be positive. If we are talking about semiconductors, so alpha must be negative. So that's why here we show inverse relation to the conductor. And if we are talking about non-ohmic conductors, it should be either negative or positive. So this question is easy to do. Doable questions. If you know the concepts, you can do it. Otherwise, you can leave it. So next, we are going for next questions. We have list one and list two. Resistivity, conductivity, EMF, conductance, and list two we have Bolt, Simon. Simon, we say it Simon. Simon. Both are no unit. Ohmmeter and mhometer. So it's opposite of resistance. So you need to take care of the unit. So basically, the questions is playing with you the unit. If you play with unit, answer will be something like this. So the resistivity, if you talk about resistivity, you know resistivity is ohmmeter. All of you know. If we talk about conductivity, so conductivity will be mhometer inverse. That's basically inverse of this one. Inverse of this one. If we talk about EMF, so it will become volt, obviously. And if you talk about conduction, so what will become? Simon. So take care of these concepts, these units in your brain, then you can do it. Either you can do this question by elimination method as well. If some of the time you miss some units, you can put elimination method, you can find the correct answer. Next question I'm giving you for, in front of you, that is list one, and this is list two, resistance, EMF, electric current, conductivity. And list two, we have this dimension, and dimension. So I'm giving you answer key. You can go through it. You can find out dimensions easily. So all of you know the dimensions. If you don't know, go through it. You can do it. So answer key will be first. Next, we are moving with second 10 questions. Next question, the resistance of a conductance is. So basically this is based on the formula that is R is equals to rho L by A. So apply this formula R is equals to rho L by A. You can get the answer for these questions easily. So it's a doable questions. You can do it. Next, we are moving for next question. Resistance of a wire. Resistance of another wire twice that of length and twice the diameter. Again, the question is same concepts you do. You can get the answers. Next questions we are SI unit of electrical conductivity. Again, I did this question right now as of now. So I hope you know these questions. So SI unit of electrical conductivity. We are talking about Simon per meter. Next questions we are moving with a piece of silver and another silicon are heated from room temperature. The resistance of. So this is again factual based questions. We have silver and silicon. So obviously silicon is what? Semiconductor. So silicon is what? Semiconductor. Take care of this concept in your brain. Silicon is semiconductor. So apply all the concepts you know for semiconductors, you will get the answer. So next we are going for next questions. So next question, the equivalent resistance of resistor in parallel order. So you can do this question easy. You can go through it. Next questions. Next questions we have IV graph of this shows the highest temperature is. So basically question is asked to see how to do these questions. V is what? I into R. So here if you see V is on x-axis. So how to do these questions? So you can say I equals to 1 by R into V. 1 by R into V. Now this is Y, this is X, this is M. So slope will give 1 by r. Take care of this thing. So you know, okay, at T1, okay, if the temperature is, which of the following is highest temperature, okay. So if see at a high temperature, resistance is high, you know. This relation, combined relation with this, the slope will give 1 by r. Slope is here, tan theta is here, 1 by r, not r. So take reciprocal and use both concepts, you will get the answer. So options I'm giving you here. So this. So if you do, this questions will come. Okay, T1 will come. Okay. So I hope you understood the concepts. Now we are moving for next questions. Okay, so next questions we have is Ohm's law is applicable to this. So ohmic conductors only. Okay, so this questions is doable, very easy questions. We are moving for next questions is this is applicable to this formula. Formula is applicable for both ohmic and non-ohmic. Okay. Formula is valid for ohmic and non-ohmic. So don't do this silly mistakes if you don't know concepts. Go through it. Definitely you can do these questions. Yeah. Next one. Move to next questions. Steady current passing through a conducting wire of this uniform cross section. So questions according to the question non-uniform. So non-uniform cross section and net charge passing through it per second is. The question is asking you net charge passing through per second is. So basically, steady current is passing through is current is passing through. You know, current is what charge per unit time. Charge per unit time. But here area is not uniform, so you can apply the conductivity, a law of continuity. What is law of continuity? I hope all of you know it. If you do this question, so what is the thing for same at any cross section? So probability of charge will be same for any cross section. So answer will be this. Next, we are going for next question. With increase of temperature, the ratio of conductivity to resistivity of a metal conductor is. The question is asking you conductivity to resistivity. So see, all of you know sigma, all of you know rho. So write the relation of sigma, write the relation of rho, and then you can do this question easily. Then you can do these questions easily. So what's the questions is the ratio, increase of temperature, the ratio of conductivity to resistivity. The ratio will decrease on increasing temperature. So next, and next we are moving for next questions. The conductivity of superconductor in the superheating state is, it's very good questions. Infinity. It's infinity. Next, we are moving for next questions. A wire of resistance 40 ohm is branched into square. The resistance between opposites. It's very good questions. Actually, wire of resistance 40 ohm. Suppose the wire has a length L. If you band this into a square, so what will be? This is L by 4. This is L by 4. This is L by 4. And this is L by 4. You know resistance is proportional to L length. So this is 40 ohm total of, so this is 10, this is 10. You can do it so on 10 and 10. Now question is asking resistance with the opposite corner. So you like this, you can apply. If the question is asking you opposite corner, you can apply the okay concepts here. See, this will come in series and then parallel, and a question will ask you between the sides. So this is series, and with parallel with this resistor. You can go through these concepts and you can do these questions easily doable, but it's very conceptual questions for PJ point of view. So you can do it easily, and I'm giving you answer key and it's calculating parts. You can go and do it. So answer will be MC Akar. Next, we are moving for next question. The best material for making resistance in resistance boxes. Again, it's good question. Again, it's factual questions. Again, it's very important questions for all exam point of view. So best material for making resistance in resistance box is constant time. It's constant time. So keep this concept in your brain. Definitely, you can do this question correctly. Next, we are moving for next question. The Blount table gives the length of the four copper rods, their diameters, their resistance between the two end of the rest are in ascending order. So you have to arrange it length, diameter, rod. See, again, it's calculation. You can do it. The table gives the four copper rods, their diameter, resistance between the two ends of the rod are in ascending. So basically, again, apply the basic formula for resistance, and you can do it. Question with these questions. If you arrange it, answer will become CADV. So you can do it. Again, apply the basic concept. Area is pi by 40 square. Again, this is good questions. Steady current is set up in a metallic wire of non-uniform cross section. Then the drift velocity is related to area of cross section. So question is asking you drift velocity. Drift velocity. If you know the formula, you can do this question easily. Okay. So we see I equals to NEAVT. All of you know this formula. Without this formula, you can't imagine this chapter. Okay. So without this chapter, for knowing this formula, should not come to this chapter. So I is what? NEABT. So we are talking about this relation. Question is playing with this relation. If you know, you can do it. If you don't know, please go through these chapters. Then only you can do these questions. Otherwise, you will feel demotivated. Next questions we are this again very good question. It's my favorite questions. So this is this and this and this and this and this. So N E dot M are corresponding electron density, charge, relationship, and mass of electron density within the resistance of the wire. Of length, Allen cross section area is given by okay resistance. Question is asking you resistance. See, if you don't know anything, you can do this question by elimination method as well. See how I'm telling you R is what rho L by A, rho L by A. So this is confirmed that L will come here, A will come here. No L, no A, wrong. No L, no wrong. No L, no wrong. No. If I don't know anything even about this okay concepts, I can do it this question. If you know, definitely you know rho is what? Rho is what? M by N E square dot. M by N E square dot. It's a very, very important and brutal concept. Without knowing this, you can't expect good marks in your examination. And sigma is what? N E square by M. N E square by M. What is sigma? N E square by M. Please take care of this relation. Definitely, you can beat the questions fastly. Next, we are moving for next questions, and. Metal block has no potential difference applied across is then the mean potential velocity of the free electrons at absolute temperature. It's again good questions. Good question, good question, good question. Question asking mean velocity of free electrons at absolute temperature is zero. Zero. Because we are talking about average. Mean is what average. Mean is what average. It's zero. Next, we are moving for next question. Steady current passes through wire of non-uniform cross section. The quantities that are dependent on cross sections are so basically what's happening. Understand the questions. Basically, what's happening? A steady current passes through the wire of non-uniform cross section. The quantity that are dependent on cross section that dependent on cross section. So all the quantities will use area. So it will come. Okay. So you know for the calculation of drift velocity, you know area comes otherwise. Okay. For electron density, resistivity, and charge crossing in a given time interval, see, it's totally blended. I already stated this questions. Charge or crossing in a given time interval is same. Yeah. So I hope you understood the concept. Next, we are moving for next question. Among the following dependence of due to velocity on electric field, Ohm's law. Ohm's law obeyed is okay. So basically, question asking you relation between electric field and drift velocity. Electric field and drift velocity, and the relation is what proportional to. The relation is what proportional relation. Okay, so you know electric field, you know drift velocity. Definitely, you can do. So try to relate the relation between drift velocity sigma and E. Drift velocity sigma and E. Drift velocity sigma and E. Next questions we are moving on. Steady currently passing through a linear conductor of non-uniform cross section. The net quantity of charge crossing any cross. I already did this question. I already did this question. You can do it independent of area cross. Independent of area cross section. Next we are moving for next question. Choose the correct statement. Difference of potential difference. This you can do. Closed circuit is called EMF circuit. Electromotive. This you can do it. Do this question. Go through the options and. So difference between the EMF of cell and the potential difference across any end of the cell is called lost volts. Lost volts. So basically what I'm talking about, E minus B. Okay, so it's lost volts. Okay, it's a basic common sense questions. There's no big concepts here. But if you know, you know. You don't know, you don't know. Internal resistance of ideal cell is this very easy question, doable for everybody. So answer is zero. Next questions we have for a cell which is discharging electric current in a circuit. V is potential difference and EMF. So basically, in a cell that is discharging, see, it's very easy questions again. Discharging, V is less than is. Okay, see, discharging is what? Discharging or V equals to E minus IR. Discharging means what? Current is flowing in the circuit. Okay, so definitely B will be less than E. Again, this is very good question. Take care of this concept. If you don't know, go through the concept. Then only you can attempt such questions. Otherwise, you can't do the questions. There is no shortcut. There is no shortcut. There is no shortcut. There is no shortcut. Come here. For a cell which is charging. Again, it's easy questions. I already explained here. V will be greater than E. Here, V will be greater than E. Next questions we are moving with. If two identical cell of EMF E and internal resistance R are connected in parallel and terminal voltage of battery, two identical cells of EMF. See, basically we are connected to identical cells and this is the parallel, so EMF will be same. In parallel, EMF will be same. So if you know, you know, you don't know, you don't know. Next questions, yes. So internal resistance is, I don't know this question. Please do these questions, okay? Please do these questions, okay? So large for primary cell, small for secondary cells, okay? So internal resistance, internal resistance, internal resistance. Go for next question. Back EMF of a cell is due to, okay, it's very easy question, doable questions. Anyone can do this question. Electrolytic polarization. Back effect of a cell is due to electrolytic polarization. So back effect of a cell is due to electrolytic polarization. Understood. Back EMF of a cell is due to electrolytic polarization. Next questions we are moving with the internal resistance of a cell depends on concentration distance between both through the options. Okay. So answer is all of the above. So internal resistance of a cell depends on concentration, definitely. Distance between the electrodes, definitely. Area of electrodes, definitely. Sure. It's good question. It's good question. I will tell you. All questions are very good. Very good. If you know, you know. You don't know, you don't know. Next question. So we are moving with direction of current in a cell is. Again, it's very easy questions and doable questions. Anyone can do this question. If you know, you know. You don't know, you don't know. So direction of current in a cell depends. Okay. Depends. You are doing charging or discharging. You are doing charging or discharging. So basically, negative pole to positive pole during discharging. Okay, must. Okay, understood. And positive pole to negative pole during charging. Again, it's very tough questions. If you know, you know, you don't know, you don't know. Next questions we are moving with. To supply maximum current, cells would be urged in. We want maximum current. So we should arrange cell in parallel so that we can provide E potential to all the circuit. Okay, why? So that we can provide E potential to all the circuit. Okay. So I hope you know the concepts, and that's why you are doing the questions. Otherwise, definitely you don't do. If you know, you know, you don't know, you don't know. If you know, you know, you don't know, no. Okay, come to the next questions. Okay. So to next 10 questions, we'll complete then. We'll set up with close. Next 10 questions. To reduce the electrolytic polarization, the depolarization used is it's the question. You know, that's manganese dioxide. So to reduce the electrolytic polarization, the depolarization used is manganese dioxide. If you know, you know, you don't know, you don't know. Next questions in front of you. That question is, when an electric cell drive current through load resistance, it's back EMF. Okay. Oppose the original EMF. Take care of this concept. Electric cell drive current through load resistance. It's a back EMF. Oppose the original EMF. Okay. Next, we are going for next question. When cells are connected in parallel. I don't know because I already did this question. Next question. Okay, sure. Terminal potential of a cell is equal to its CME. I don't know. See, if external resistance is infinity or internal resistance is 0. Next question. Suppose the correct estimate is this. Correct answer is 1. Series combination cell is preferred when external resistance is large compared to internal resistance of the cell. Okay, so when external resistance is large compared to internal resistance of a cell, parallel combination cell is preferred when external resistance is small. to internal resistance of itself. This is again doable, but if you know, you know, you don't know, you don't know. So next questions, next 6 questions we will do it. That it's over. It's over. It's over. It's exit time. Next questions we have. Oh, this one is discharging cell, the cell short circuited, cell in open circuit, and this. It's very good question. It's very good questions. It's very doable questions. If you know, you know, you don't know, you don't know, you know, you know, you don't know, you don't know. Please do this question correctly. So if you do this question, so charging opposite. So obviously I said you B will be greater than A. So if B is greater than discharging opposite, B is less than A, B is less than A. And cell short circuited, B is what? Zero. No potential difference. And cell in open circuit, you open circuit, its B is equals to E. So I hope you understood my points, what I'm trying to convey. Sure. If you know, you know, you don't know, you don't know, you don't know, you don't know. Next questions we have. Terminal voltage of a cell is greater than CMF when it is. I don't know. I don't know. You know. Being charged. Next question. Which of the following is standard cell? Daniel cell, cadmium cell, okay, Lachlan cell and lead accumulator. Cadmium cell is a standard cell. 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 Cadmium cell is standard cell. It's easy question. If you know, you know. You don't know, you don't know. Next question. Analysis. This is of internal resistance is okay. 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 First connecting parallel and then connecting to series across the resistance R. So basically external resistance we have R only, and basically we are playing with an identical cell. Identical cell like this we are doing parallel and series. So basically you have to play with R. You have to play with R. So intercurrent through R is the same in both cases. I don't I don't. So you can do this question very easy question. So current is same is R is capital R is equals to small r, then only it's possible. So if current is same in both the cases, if current is same in both the cases, okay. Sure, capital R should be equals to small r. We are moving for next question. Question. The electric power transfer bias to an external resistance is maximum when the external voltage resistance. I don't know. It's very easy question. It's very easy question. Very easy question. Answer is R. Answer is R. Answer is R. Capital R equals to small r. So you can do this question by derivations. You can do this question by differentiations. Okay. So capital R equals to small r power will be maximum at R equals to R. Next questions we are moving with a heater coil is cut into two equal parts. Only one part is used in the heater. I don't know. I don't know. I don't know. It's easy questions. You can do it very easily because see what you are doing. What you are doing? You are dividing resistance R by 2. R by 2. So resistance is halved. Resistance is halved. Obviously, heat generation. Question asking about heat generation. You have to play with voltage. If you play with current, it will be wrong. You have to play with voltage, you will get your answer. Sure. So it's exit time now. It's exit time now. It's exit time now.